Right, so this is the phase 4 presentation for our BSIS 308 group. The introduction. So the global music industry has been transformed from streaming platforms like Spotify, where millions of artists and tracks compete for listener attention. Understanding what drives the popularity of a track is key for producers, artists, and marketers to understand ways to reach a wider audience. This report analyzes Spotify data to explain how artist characteristics, listener behavior, and track attributes influence how popular a track is. And our key research question is the problem we want to address using the Spotify dataset is what factors impact track popularity. More specifically, we want to analyze in what ways artist characteristics, track attributes, and album features relate to a song going worldwide. So our first dataset was our Spotify Global Music dataset. It's from 2009 to 2025, uses 8,582 songs to observe music streaming trends on Spotify. The data includes key tracks and artist variables such as track duration, genre, popularity, and the followers of each artist. The data reflects consumer behavior and listener engagement inside the music streaming industry. It supports business analytic techniques like predictive modeling and trend analysis. It's very useful in finding patterns as to what makes a song popular than others. And the data was created and published on a public source called Kaggle. And then the second data set was global music streaming trends and listener insights. This one represents 5,000 global music streaming users and their listening behavior across Spotify. This includes demographic data, listening habits, and preferred times of streaming, combines numerical and categorical data for deep analysis, and the consumption varies by age group, country, and the time of day. Helps identify in-depth listeners' behavior across the globe and data built in and published on the public source Kaggle. And on the right is an image which displays Spotify listeners across the globe, and the darker shades mean more listeners in that country. And then our analytic process, the steps we take is viewing the data with visualizations to generate ideas about said data. We use simple descriptive statistics to find the average, mean, mode, and standard deviation of different variables. And lastly, perform regression analysis to see if we can try and predict a dependent variable. So the first finding on our first data set was a tree map that we created, which compares the artist names with the sum of artist followers per track name in the data set. And as seen on the left, popular names like Taylor Swift and The Weeknd with the most followers are displayed there. And towards the bottom right is artists that aren't as popular. It's an easy to understand visualization of what artists are popular and who's on the lower end of that data set. Uh, Findings for Spotify Global Music Dataset. This one is a list of songs along with their track duration and popularity score. Most of the songs are between about 2 and 4 minutes long, which is a common length for popular music. From the table, it does not look like longer songs are always more popular or that shorter songs are less popular. Instead, songs of many different lengths can have high or low popularity. Overall, the table suggests that there's no strong relationship between how long a song is and how popular it is. Now Quinn's going to go into the rest of the findings.
So for the rest of our visualizations for our first data set, this visualization is a bubble chart that displays the relation between artist popularity and track popular or artist popularity is the x-axis, track popularity is the y, and then the size of the bubble is how many followers that artist has. Um, each circle represents an artist's individual track popularity in the data set. Um, and oh, I just repeated myself. The bubble chart shows a positive relationship between artist popularity and track popularity. Most of the data is condensed in the lower left area of the visualization. explained that many artists have low popularity scores. But then when you look in the middle of this chart, you see The Weeknd is more popular than the lower left corner of the chart. And then in the top right is Taylor Swift, who has the most popularity in track popularity. And then this visualization is a stack bubble chart, and it sort of shows like similar results to the previous slide, but it's just a different way to look at it. Um, you can see with the dark blue bubble with Taylor Swift, it's just the same idea. She's like just in a whole other area compared to all the other artists, has higher popularity and track popularity compared to other artists. This is a simple scatter chart which shows the artist's followers based on the artist's popularity. This chart shows a bit of an curve where the as the artist's popularity rises, their number of followers increases at more rapid rate. And you can see this just beyond the artist popularity of like around 60, and it sort of just kicks up right after that. This scatter chart shows track popularity uh, based on track duration. And this is sort of similar to the table from earlier, but just in scatter chart visuals. And this shows that there isn't really a relation between track duration and track popularity, which is important to keep in mind for our regression analysis. So after all of our visualizations, we have simple descriptive statistics where we have the mean, median, mode, and standard deviations for track popularity, artist followers, and track duration. Uh, so the means for track popularity 52.36, median 58, mode is 0, standard deviation 23.82, artist popularity mean of 69.73, median 74, mode 88, standard deviation 19.65. Artist followers, our mean is 24,134,719. Median 6 6,105,547. Mode 145,396,321. Standard deviation 38 million 32,804. Track duration, we found a mean of 3.49 minutes, a median of 3.44 minutes, a mode of 3.67 minutes, and a standard deviation of 1.06 minutes. And now we go on to our regression analysis. So initially, we were going to use the variables artist popularity, artist followers, and track duration. However, with our findings for track duration, we decided to not include it because it like the visualization showed that there wasn't really any relation to track popularity and track duration, so we did not include that in our regression analysis. Overall, our findings for our regression analysis to predict track popularity, we used just artist popularity and artist followers. And the overall regression is significant, as significance F is practically 0. And our two variables are significant as well, as they have p-values of pretty much 0 as well. However, our the R squared of 0.22 or 22.5% shows that this regression is fairly limited in being able to estimate a track popularity based on these variables. However, even with that, we can have a potential equation of predicting track popularity, which is y equals 8.69 plus 0.65 x for our first variable, and then negative 0. pr- pretty much 0.00000068x for the second variable. So while we do have this equation, it is very limited just given the r squared. So our results, the findings for our Spotify Global Music Dataset gives us the following. We can rule that track duration does not have any predicting factor for a track's popularity, and an artist's popularity and follower count are good predictors for a track's popularity. Although it is limited, we have an equation that might be able to predict a track's popularity based on those two variables of artist popularity and follower count.
These were some of our findings for our trends and listener insights from all of our data sets. For the descriptive statistics, the following table shows the mean, median, mode, and standard deviation of listeners' ages, minutes streamed per day, and number of songs liked. So you see our mean for the listeners' age, minutes streamed per day, and number of songs liked is actually pretty similar to our median. Minus the minutes streamed per day, that's a little bit more of a difference than the other two. But then if you go on to mode and standard deviation, they're not similar at all. And then this is just continued for our findings for our trends and listener insights. This visualization is two pie charts that show the difference between listening times of the data of the day based on free and premium listeners. Orange shows how many listens are in the morning. Blue shows how many listen in the afternoon. And red shows how many listen at night. This creates a simple presentation of subscriptions type based on a listener's preferred listening time. And then again, this is just more of our trends that we found throughout our data collection. This visualization is a histogram that shows the number of different age groups that listen to specific genres of music. This visualization can help with providing insights into which genres of music are most popular and genres that are the least popular with each age group. Also, this is important to note, the visualization also considers all the different music streaming apps, not just Spotify. If we wanted to view this for only for Spotify, we could filter out the other apps included in this visualization. So then you can see at the top, you can see the genre and see where they peaked with their ages down at the bottom. So we have classical, country, EDM, hip hop, jazz, metal, pop, R&B, reggae, rock, and I'm sure you can also list a few, but these were the most popular in the genres that I looked for. Again, this is just more of our findings in the data that we found. The following is a column chart, which has bins of age groups and shows the total number of listeners in that age group. There's quite an equal representation among age groups, apart from the ages 12 to 19, 34 to 38, and 54 to 56. Other than those few representations, it seems like this data set tried to get data among age groups equally. Continued more of our findings. The following chart splits up the different listening times of the day, afternoon, morning, and night, and shows the total minutes streamed during the day at that time for each country in the dataset. Australia, Brazil, Canada, France, Germany, India, Japan, South Korea, UK, and the US. From the chart, the popular listening time is at night for all of the countries, because who doesn't like listening to some music right before you go to bed? And then this is another regression analysis that we have. For a regression analysis, we initially wanted to form an equation for our listeners' age based on their minutes streamed per day and their subscription type. We wanted to have a significant level of 0.05 for the regression equation itself and for any of the variables. Looking at the significance F and the p-values for both minutes streamed per day and subscriptions type, we can rule that the overall regression is not significant, and the variables we used were also not significant. Also, looking at the R squared of 1.76 exponentially to -5, this shows that this is not an effective way to try and estimate a listener's age. And then in total, the results for our trends that we found, listener base is diverse and evenly distributed across all age groups. Average listening time is approximately 5 hours a day, but usage always varies. Nighttime is the most popular listening period in all countries. Well, the ones that we researched. Engagement levels changed frequently, with users liking songs in comparison to others. Regression analysis found no meaningful relationship between listening time, subscription type, and age. This explains that streaming behavior is complex and cannot be easily predicted.
For assumptions, independence of observations, data is not influenced by others. Listening behavior is stable over time and not heavily affected by short-term trends. And regarding linear regression, linear relationship is assumed between variables. Errors are random and distributed normally, and no strong correlation between the predictors. For potential biases and cognitive errors, overconfidence bias, which may place overconfidence in regression results, confirmation bias, which a large focus on patterns that support our expectations, not potential outliers or conflicting evidence, and correlation versus causation error, which is assumption that artist popularity equals track popularity, and other factors may alter this. Practical implications, some possible decisions are prioritizing promotion with artists with strong followings, reevaluating investment in lesser known artists, avoiding using track duration as key strategy factors, and using caution when applying predictive models. For some miscellaneous stuff, ways to expand on our findings. Extensive or relevant variables such as genre, marketing, playlist placement, and social media engagement, and more. Applying more advanced models such as genre or region for deeper insights, and addressing outliers and refining research focus, such as predicting user behavior. And these are our references that we had used. So I think that concludes our presentation.